Hey everyone, and welcome to this tutorial series on Arduino for complete beginners. The video you're watching now is actually the complete series that I've put together in just one big video. In this series, you are going to learn how to get started with Arduino step by step in a practical way. If you don't know anything about Arduino, this tutorial series is for you. And on the other hand, if you are already familiar with Arduino but you feel that you could need a quick refresher of the basics, well, the following tutorials are also going to help. And just before we get started, this tutorial series is actually a free extract of a much longer Arduino course. If you're interested, check out the link in the description. And now let's get started with the series. What is Arduino? What can you do with it? And also, what kind of Arduino board are we going to use? Very simply put, Arduino combines hardware with software in a perfect way for beginners to start creating hardware projects and control them with simple programming. And before we even go further, what can you do with an Arduino board? Well, actually, a lot of things. Two of the most common project fields are home automation and robotics. For example, with Arduino, you can create an alarm system in your home, control the movement of a robot, detect obstacles, make some music, create a weather station, work with IoT or Internet of Things, etc., etc. An Arduino board is a small electronic board which contains what is called a microcontroller. The microcontroller will be responsible for executing the programs that you have written. Note that a microcontroller is quite different from what runs typical computers, which are microprocessors. To give you an idea, the microcontroller on the Arduino board is running at 16 MHz and has 2 KB of memory. On a standard computer, you can get, for example, a multi-core 2 GHz CPU and 8 GB of RAM. When you look at the numbers, well, the difference is huge. So, with a microcontroller and Arduino, you can see that you won't be able to do things that require a lot of computation power. For example, processing images. But on the other hand, a microcontroller is much cheaper than a typical laptop and is also much closer to hardware. You will see that with Arduino, you can easily control many hardware components, and the computation power is in fact good enough to run many projects, so don't worry about that. You just have to know that computers and electronic boards, such as the Arduino, are different things, made for different applications. Now, where can you find microcontrollers in everyday life? Well, they are everywhere. Every day you see or interact with many electronic devices that are run by microcontrollers. For example, you can find microcontrollers in your phone, a microwave, a washing machine, a car, a plane, etc., etc. Basically, any electronic machine contains one or many microcontrollers. Now, the thing is that working with electronics, software, and microcontrollers in general is quite difficult, and there is a big learning curve before you can do anything. And here comes Arduino. Thanks to Arduino and the Arduino boards, it is now much easier to start working with electronics and microcontrollers. Arduino is the easiest way to get a first step in the microcontroller and the electronics world. With an Arduino board, as you will see in this course, you can create fun and interesting hardware projects in no time. And after learning Arduino, if you want, you can dive deeper into the microcontroller world and reach a more advanced level, which can lead you to more projects and, for example, a great job. So with Arduino, no complicated setup at all. Just install a software that is called the Arduino IDE or Arduino Integrated Development Environment, and that's it. Then you can directly create circuits and upload programs to your board. I will explain all that step by step in this course. Now, when was Arduino created? Well, first, when we speak about the name Arduino, we speak about the Arduino project, initiated in 2003 with the goal of providing a low-cost and easy way for any people to start hardware projects with microcontrollers. The first created board was named Arduino Uno and is still currently the most popular to get started with Arduino. After the Uno, many other Arduino boards were created, and today you can still regularly see new boards that are released. So among the most commonly used boards, you can for example find the Arduino Nano, which is basically the same as Uno, but running on a much smaller board. You also have the Arduino Mega, which contains more hardware connectors and is a little bit more powerful. Arduino Uno, Nano and Mega are the three most common boards you will find in many projects. And then you have so many other boards which contain specific functionalities for specific applications. So with all those boards, why Arduino Uno? Well, this is the most popular one, easier to start and learn with, and also with enough hardware connections to start many projects. If you already have a Nano or a Mega board, note that this is totally fine and this will work the same for you. And after this course, if you have a different project and you find that another Arduino board would be more appropriate, then go ahead and get a new one. The Arduino hardware and software are open source. You can find them on the internet, for example on websites such as GitHub. And behind such a big open source project, you then also have a big open source community. This aspect is what makes Arduino great for your projects. You can easily share any project you have, get feedback from more experienced users, participate in other people's projects, learn and discuss with many other people. And the fact that Arduino Uno is the most popular means that you will encounter even more projects and help using this board on the internet. To finish with the Arduino Uno board, well, what can you actually find on that board? The first and most important thing is the microcontroller here. This will run your code on the board and interact with the different hardware components you add to your circuit. Then you have a USB port so that you can power on and connect the Arduino board to your computer. You also get a DC power jack if you need external power supply. You should also have a push button on the board, which is named the reset button, to restart your program. We will talk about this more later in the course. Directly on the board, you have other components to make the board run correctly, but you don't need to worry about those for now because that's not really important to get started. And last but not least, the hardware connectors to plug different hardware components. On the Arduino Uno, you get 14 digital pins, 6 analog pins, and some power pins. Alright, that's pretty much it for the board. Note that because Arduino is an open source project with open source hardware, then you can actually find many different Arduino boards produced by different manufacturers. Depending on the board, the color and layout may be different, but the pin layout and microcontroller don't change, so basically nothing changes for you. Welcome back everyone, this is episode number 2 of this tutorial series on Arduino for complete beginners. So in this tutorial we will get everything set up by installing and configuring the Arduino IDE so that you can start to send programs to your Arduino. After that, you will be 100% ready for the next tutorials. And here, to follow the tutorial, you will need to have with you an Arduino board as well as a USB cable to connect the board to your computer. Let's now install the Arduino IDE. So first of all, what you can do is open a new web browser and you can type on Google Arduino IDE. Okay, you will get to a page here on arduino.cc website. So from there you can go on the download section here. If you don't have this download section here, well, you should have a menu somewhere on the top where you can find this section. And now here you can see on the right we have all of the different operating systems that you can use, so Windows, Linux and Mac OS. So choose whatever version corresponds to your operating system. So for me I have Windows 10, I'm going to use here Windows 7 and New Year. So you click here and this will make you save a file, an executable file. So you save the file, okay? And once the file is downloaded, so this can take a few minutes depending on your internet connection speed, you can just click on that executable, so you can just execute it. You can say yes here, and then you can install the Arduino IDE just like you would install any other software. So make sure that all the boxes are checked here. Next, and if you want to change the path, you can do that here and then install. And you can wait. This would take a few minutes maybe. All right, and now the Arduino IDE is correctly installed, so you can close that. And to be able to start the Arduino IDE, well, in your desktop, you should have now a shortcut. Here you can double click on this shortcut. And the Arduino IDE is correctly installed, you just launched it. And if you don't have a shortcut, well, you can directly go on the search bar here and search for Arduino and simply open the Arduino IDE. Before we go any further, there are some small improvements you can do to get a better experience when using the Arduino IDE. So first, open the Arduino IDE and you might notice that the text may be quite small for you to read. And when you program, it's actually better to be comfortable with the size of the text, okay? So what you can do first is press Ctrl or Command and use the scroll of the mouse, okay, to zoom in and zoom out, okay? And this way you can actually make the size of the text bigger. If you want a more permanent solution, you can go here on File, okay, open Preferences, and here you can see the font size. So 15 was the one I just have here with the zoom with the mouse, and you can choose any font you want. I'm gonna put 18 for example, and I'm going also to scale the interface a little bit to 130%. You don't need to change that, okay? This will make, for example, the green buttons here bigger, but what you can do is keep this with automatic and change the font size with something that you are comfortable with, okay? It may be 18, it may be 16, or it may be 22, whatever makes you more comfortable. I'm going to click on OK, and actually I'm going to restart the Arduino IDE. Okay, so now it's actually much better. One thing we can do also is we go back to Preferences. We can put line number. So display line number, you can check this option, click on OK, and now you have the line numbers here. This will make it easier for you when you need to communicate with other people about your code, and your overall program will be a little bit more readable. And now the last thing I'm going to do is to actually change the font, okay, for the text, because as you can see, maybe the font here is not the best one for readability purpose. So what I'm going to do is go on File, Preferences again, and here you can't directly change the font on this menu. You need to go to this file here. So on the bottom you should have a file. This will, you click on this will open a new file manager. Okay, and what I'm going to do, so I'm going to close the Arduino IDE. Now we are on this file manager here, and I'm going to click on preferences.txt. So I'm going to open it, and I'm going to search for font. So editor.font here, we just found it. And the font, the basic one, is monospaced here on Windows. And then you have, as you can see, the size of the font. And what I'm going to do is I'm going to change monospaced to Consolas. So C-O-N-S-O-L-A-S. This will be the font I will use, and if you want, you can also change and see if it's better for you. And it's very important, note that you should first quit the Arduino IDE and then edit the file. Okay, don't edit the file while the Arduino IDE is still running. So I can save the file, okay, save preferences.txt, and now I can start Arduino IDE again, and as you can see, the font here is actually better for readability. And one quick note here, actually here you can see the font and then plain. You may want to change it to bold, but actually this option doesn't work for now with the Arduino IDE. So you can just change the font here and then the size. Great, you now have the Arduino IDE installed and set up on your computer. Now take your Arduino board and the USB cable which goes with it. Simply plug your Arduino to your computer using the cable. And now how to make your Arduino IDE know that your Arduino board is connected to your computer. Well, you can go on Tools menu here and you will need to check two things. First, here, board. So Tools and board. You will have different kind of board. So for example, Arduino Uno, Arduino Nano, Mega, Leonardo, etc. So if you are using an Arduino Uno like I'm using now, make sure that Arduino Uno is checked here. Okay, this is the first step. And then you will have here to check the port. So Tools, Port, and make sure that the correct port for the correct board is selected. You may have multiple ports here and you maybe don't know which one corresponds to your Arduino. So for me, it's already detected as an Arduino Uno, okay? But if you don't know which port is which, well, there is a simple way to know. You can, so click here, you can unplug your Arduino board, so disconnect it from your computer. Then you go on Tools. So you can see I don't have any port selected, or maybe you will have different ones, for example, COM1, COM3, etc. And then you can plug your Arduino back, okay, and go on Tools again, and you should see now the port is here. You can also click on here, Get Board Info. Okay, this will tell you, this should tell you, depends on the board, but what kind of board do you have, so you are sure you don't make any mistake. Okay, and this is a basic program, so this is the minimum code for an Arduino program. This code does actually nothing. I'm going to explain all that later in the course. Okay, but for now, what you can do, once you are sure that board and ports are correct here, you can click on Verify, so this button. This will compile the code. Okay, you can see here the green bar, okay, down compiling, and then you can click on the Upload button here. And this will so compile and upload the code to your Arduino. And once you see down uploading, it means that this program is actually uploaded correctly to your physical Arduino board. Hey, welcome back. This is episode number 3 of this tutorial series on Arduino for complete beginners. So you have the Arduino IDE installed and correctly configured on your computer. You can compile and upload the code to your Arduino board. Now let's try to understand how a program works and what is this text that you can see on the screen here. And let's go. When you start your Arduino IDE, you will directly get a new empty program. But as you can see here, in fact, the program is not really empty. It already contains two functions, void setup and void loop. So for any Arduino program you create, this is the minimum code you should have. If one of those functions is missing, you won't be able to compile and upload the code to your Arduino board. And when creating your own program, you will write some code inside each of those functions. This code will then be executed on the Arduino board. So the first thing you can see is that the functions are empty, okay? So when you run the program, what will happen? So first of all, if you put any instruction here at the beginning of your program, this will be executed, and then the void setup function will be executed first. So whatever code you put between those two curly brackets here will be executed first. After it is executed once and only once, the code inside the void loop function will be executed in what we can call an infinite loop. So basically all the code here will be executed, and once it is finished, it will be executed again and again and all over again. So first, the code in the void setup is executed once, and then the code in the void loop is executed an infinite number of times until you simply restart the program or you shut down your Arduino. And inside the function, so inside the void setup, for example, the instructions will be executed line by line. So first line 5 and then line 6, etc. Okay, and the same for the void loop function. All the lines will be executed one by one, and this is also a commented line. So we are going to come back to those functions quite a few times in this course, but basically what you will write inside the void setup function is the code to initialize your program, for example, to initialize variable, to set up a sensor, or to set up a communication. So everything that you need to set up at the beginning of your program and that you basically need to set up once. And then in the loop function, you rewrite your application code. So that will be the code that will run all over again until the Arduino board is powered off or restarted. Hey, welcome back everybody. This is episode number 4 of this tutorial series on Arduino for complete beginners. Let's now create your first real Arduino program. So what are we going to do in this first program? Well, there is an already existing LED directly integrated on the Arduino board, so we don't need to add any external hardware. We can just try to make this LED blink. Note that depending on your Arduino version, the LED may be located in a different place, but it will not be very hard to find. So back to our program here. You have void setup and void loop. So now you know that void setup is the function that will be called first and will be called only once, and then void loop will be called after setup and will be called an infinite amount of time until you simply restart or power off your Arduino. So because we are using an LED, we need to set it up, okay, on the void setup function. Okay, and the LED is actually connected to a digital pin on Arduino, so we are going to see what are digital pins a little bit later on this course. And the first thing we need to do when we use a digital pin is actually to set it up with the pin mode function. So pin lowercase and then M uppercase pin mode, and you can see it should turn orange or at least a different color. Okay, if you have this, it's good. Means that the function has been recognized as an Arduino function. So the number of the pin here is 13. This is simply the pin where the LED, the integrated LED, is connected to. And then we can put a comma. So we open the parentheses, 13. We can put a comma and then all uppercase outputs. And this should turn blue here. We close the parentheses and we add a semicolon. The semicolon is very important. It means that this is the end of one instruction. So basically you are going to write the code, so one instruction per line, but this is not what defines the limit between instructions. The limit between instructions is the semicolon. So if you forget a semicolon, you will probably get an error here when you try to compile the code. So make sure you don't forget that. All right, and you can see here we have a comment. Maybe we can remove that comment. Okay, put your setup code here to run once, so we already know that. And maybe we can just add a new command here. Let's say set LED pin to output. So this is just a command, so this line will not be executed. But you can see a command is very useful to say what we are going to do or to explain the next line. So this line is pretty obvious, but you can get a feeling of how to use commands. Great, so now the void setup will be executed once. The mode for the pin will be set to output. Okay, we have input and output. We select output because this is an LED. We want to control the LED, so output. And then in the loop, so I'm going to remove also that comment that we don't need. So in the loop, we are going to make the LED blink. So the first thing we can do is to call the function digital right. So again, you should see it turning orange. Okay, digital and then right with W uppercase. We open the parentheses and now we need to give also the name of the pin, so the number of the pin, 13, like we did here. And here we need to simply put high or low. So I'm going to put high, always uppercase here. Okay, it should turn blue. I close the parentheses and I don't forget the semicolon. So this basically will turn the pin number 13 to high, to state high. And what this means with the LED is that the LED will be powered on. Also, one little note here, you can see we have an indentation of 2 spaces here. So the indentation is actually not required for the program to work. This is just for readability, okay? So whenever I enter a new block of code like this with curly brackets, I'm going to use 2 new spaces for indentation. And after we have powered on the LED, what we want to do if we want to make it blink is, of course, we need to power it off. So digital right with pin 13, okay, the same, and then low, uppercase, LOW. We close the parentheses and the semicolon. All right, now the thing is, if we just start the program like this, what will happen is you will see the LED always high or always powered on. And this is because, well, the code inside the void loop will be run at full speed. Okay, and full speed for Arduino is a few hundred megahertz. So when you compare that to what we as humans are able to see, well, this is way too fast for us to see the LED blink. So what we need to do is to add a small delay. Okay, we need to make the program stop between those 2 instructions. Okay, and what we are going to do is to use the function delay. Okay, so delay like this with parentheses, and let's put 1000. We close the parentheses and semicolon. So delay will simply stop here for the amount of millisecond that you provide here. This is not second, this is millisecond. So 1000 milliseconds means 1 second. Okay, so if we look at how the program will be run, so first the setup and then the loop, we power on the LED, we wait for 1 second, then we power off the LED, and then what will happen here is that we directly come back to the beginning of the void loop function. So just after we power it off, we are going to power on the LED, so we need to also add a delay here. Okay, because otherwise we will not be able to see the LED powered off, because it will directly be powered on just after that. All right, I know the program is complete, so if you want, you could add also different comments here to describe what you are doing. And to make sure you understand how the loop works, well, basically, I could just copy and paste that code an infinite number of times, okay, and this is how the code will be executed. Instead, I just need to provide the code once, and I know that after line 10, so we close the loop function will be called again, and we go back to line 7. All right, it looks good. So now we can upload this program to our Arduino board. The first thing I'm going to do is I'm going to compile with this button, with verify button. I'm going to compile the code, and it will ask you to save the sketch. So with Arduino, a program is called a sketch, okay? So it will ask you to save the sketch, and what you can do is simply give a name, let's say first program. Save. Okay, it will compile. And let's see if we have any error. Okay, you can see here done compiling. So if you have this, it means it was successful, and you have some information about space usage and stuff like this. Now let's say that I forgot this semicolon here, and I verify again. So when I verify, it will save the file also. And you can see here we have an error, so we have quite a bit of text. And at the end, you can see expected semicolon before delay. So if you make some error, you will get an explanation here. So the explanation may be clear or not so clear, depends what kind of error you make, but here it's quite clear. Okay, before the delay, we don't have any semicolon. I'm going to add it here, and now it works. Okay, so plug your Arduino board to your computer, and then with tools, board, make sure that the correct board is selected. So for me, it is Arduino Uno, and make sure that you have the correct port. Now I can upload the code. You can see down uploading, and we can see here that the LED on the Arduino is blinking every 1 second. Hey, I hope you're learning a lot, and I also hope you like this tutorial. If you find it useful, then you can check out the full course named Arduino for Beginners, which contains actually 7 times more content than this 2 hours tutorial. I will leave a link in the description if you are interested. Alright, and let's continue with the video. Hey, welcome back. This is episode number 5 of this tutorial series on Arduino for complete beginners. You now have created and uploaded your first Arduino program. And before we go further, there is one thing you need to learn is how to use the serial monitor. So basically the problem we are trying to solve here is how to get some information about what's happening in the program from the Arduino to our computer. Basically, if you are familiar with the term, we are wanting to get some logging functionality. And because the code is running on the Arduino board and not on your computer, well, we can't just log stuff on the Arduino because we won't be able to see it. We need to use a special form of communication between Arduino and our computer to be able to get some information, and that is serial communication. And good news, the serial communication is actually going through the USB cable. You don't need any other hardware setup. So let's see how serial works. I'm going to remove that command. You can start by writing serial with uppercase. Okay, you should see it turn orange. Dot begin. Okay, so you open parentheses and inside you are going to put 9600. And don't forget the semicolon. Okay, this will initialize serial communication. And of course, we put it in the setup function because this is something that we are going to do only once at the beginning of the program. And this number here is called the baud rate. So basically, how fast the data transfer will be. And we are going to use this value because this is a pretty common and classic value for Arduino. So after we have initialized serial communication, we can do serial.print or serial.println. Okay, we're going to use println to simply print some text. Hello Arduino. So don't forget here the quotes. Okay, to define this will be a string. Okay, you close the parentheses and add the semicolon. Okay, so now I can verify the code and I can upload directly, which will first verify and then upload. Let's name the project debug or test debug. Okay, compiling, uploading, and down uploading. So now, well, this code is running on the Arduino, but how can we actually get this data here? Well, you need to open the serial monitor, and to open the serial monitor here, you can click on here, you can see serial monitor on this icon here. And here, well, you don't see anything is because the setup is not quite correct here. So let's look at the bottom of this window. So you can leave auto scroll checked and this unchecked. And then here it's important that you check no line ending. And then here you have to choose a baud rate. Okay, so you have different numbers which are pretty common for Arduino. And as you can see here, we have a baud rate of 115,200. But in our program, we have a baud rate of 9,600. So this is not the same baud rate, which means this is not the same speed of transfer, and which means that we simply can't communicate between the two, between the Arduino and between the serial monitor here on the computer. So you need to provide the same baud rate, okay? I'm going to use 9600. And now, so this will actually make the Arduino restart. And now you can see, hello Arduino. Great, so make sure you have the same baud rate between your program and the serial monitor. This is one of the most common mistakes when you begin. And now, well, that's great because whatever we want to print on the Arduino, we will be able to see it on the serial monitor. So we have the debug functionality with logging. And now I'm going to make a few additions to this program just so you can see another time how the setup and loop functions are working. So here in the loop, what I'm going to do is do serial.println. Let's say in the loop. Okay, and then delay 500 milliseconds. So in the loop, I'm going to print, so in the loop, the text, and wait for 0.5 seconds. And also, so with println, it will print plus add a new line. Okay, if you just use print, it will print, but whatever text you print will be added to directly to the last piece of string you have printed. So what you want to do usually is to use println if you want to print one text per line. And now let's upload this code. I can open the serial monitor and you will see hello Arduino and then in the loop, etc. Okay, so I'm going to remove auto scroll here. So you can clearly see that the code inside the setup function is executed once and the code inside the loop function is executed, well, an infinite number of times. And now I'm just going to show you very quickly what are the different ways to restart an Arduino program. So that first of all, you will not be surprised if the program restarts and you don't know why. And second, knowing this is great so you can debug more efficiently, especially with the serial monitor. So the first obvious way, of course, is to power off your Arduino. For example, you unplug the USB cable and then you plug it back again to your computer. This will power off the Arduino and then power on the Arduino. And once the Arduino is powered on, the program directly starts. Okay, but this is maybe not the best option whenever you want to restart. Okay, you want to keep your Arduino plugged to your computer. So what you can do is, you can see here we have a red button. Okay, this is a red push button on the Arduino. And this is called the reset button. So here it's on the top left. It might be in a different place for you depending on your Arduino board. And simply if you press this button, then the program will reset. So simple way, I'm going to test that. All right. So I've opened the serial monitor with this program, okay, that you already know. And now I'm going to press the reset button. And you can see we have hello Arduino again. So the program has been reset because we have started again from the setup function. Okay, and now from the software side, so directly from your computer, how to restart the program? Well, actually, if you open the serial monitor again, so if you close it and open it, this will reset the program. As you can see here, hello Arduino. If I close it and open it again, this will restart the program. And to restart, you can also actually upload the code again. So if I upload the code, well, uploading and then down uploading, and the program has been restarted. So I can check that also with the serial monitor. So I click on this, the program will restart. Okay, and now I'm going to upload again. You can see it kind of stuck here on the serial monitor, and then hello Arduino. Okay, you can see the program has restarted. All right, so to restart, you can simply, this is maybe the easiest way, is simply to press the reset button on the Arduino. Otherwise, you can just open and close the serial monitor. But note that this works only for some Arduino boards. So for example, Uno, Mega and Nano, it's fine. But other boards like Leonardo, this will not work. So the most universal way to restart from the Arduino IDE directly is you can simply re-upload the code. Okay, and this will restart the program. And welcome back. This is episode number 6 of this tutorial series on Arduino for complete beginners. This tutorial is actually a challenge I'm gonna give you. So first I will explain what you have to do, and then I will do the solution with you step by step. And what is the challenge? First I'm going to do is to go to File, New, okay? So let's create a new project, a new empty project. And here you will basically combine the two first programs we have created, so the blink LED and the serial monitor for debugging. What you need to do is to make the LED blink, but a little bit differently. You will power on the LED for 2 seconds and then power it off for 1 second. Also, when you power on the LED, you will print something with the serial monitor, for example, LED on. And when you power off the LED, you will print also something else, for example, LED off. So a mix of blink and serial communication, and actually you can use the 2 previous examples to get inspiration to solve this challenge. Alright, and now you can press pause on the video, try to do the challenge by yourself, and then watch the solution. And here is the solution to this first challenge, or what I also call activity. So I'm going to remove that commented lines that we don't need anymore. And so we need to blink an LED and also to use the serial communication. So what I'm going to do is to use pin mode with 13 and output to initialize the LED. So to initialize the pin for the LED, and then serial.begin with 9600. So there is not really any order specific for that program here. Both instructions are different and don't need each other to work. But what I'm going to do is to first initialize the serial communication. Alright, everything is set up. Now in the loop, what we can do is to make the LED blink. So digital write 13 high, and then we wait for, so we need to power it on for 2 seconds. So I'm going to wait for 2000 milliseconds. Okay, and then digital write 13 with low, and another delay of 1 second this time, so 1000 milliseconds. So with this, we should be able to see the LED powered on for 2 seconds and then powered off for 1 second. And we also want to print something when we power on the LED. So let's say here we can put serial.println with LED on. And again, don't forget the semicolon, okay, at the end of every instruction. So we print LED on, we power on the LED. Then we wait for 2 seconds, and then we can print LED off before we power off the LED, and then we wait for 1 second. Alright, so that is the complete code for this activity. Now what I'm going to do first, I'm going to verify. So let's name it activity 1. I save. You can see down compiling. Great, so it's working. Now let's make sure in tools that we have Arduino Uno and the correct board and the correct port. We can upload the program. I'm going to open the serial monitor. So you can see the LED blink on and off, and when the LED turns on, the serial monitor also prints LED on, and when the LED turns off, the serial monitor prints LED off. Welcome back everybody, this is episode number 7 of this tutorial series on Arduino for complete beginners. So in this tutorial and in the next few ones, we are going to start looking at the hardware side of Arduino and start to create circuits. To create a circuit, we are going to use a component called a breadboard, and in this video I'm going to explain to you how it works. And to explain that, I'm going to use a real physical breadboard, of course, but also an online simulation called Tinkercad, because with this interface you're going to understand better and faster. So you don't need the simulation, but if you also want to get it, I'm going to show you how to set it up. So everything is in a web browser and everything is free. You just type Tinkercad on Google like this, and you go on tinkercad.com. Okay, you have the URL, and you will get to a page similar to this, and you can just click here on Join Now, okay, and create your account. So create a personal account, and then, well, you can just sign up with email, Google, Apple, or, well, whatever you want. And then once you have successfully signed up and you have also signed in, well, you will get to this. You go simply on the circuit menu. Okay, I already have many circuits here, but for you it's going to be empty. And you click on Create New Circuit. And that's from where I'm going to start the explanations. A breadboard is a super useful tool to prototype any circuit with your Arduino. Without a breadboard, you would have to solder all components in a circuit so they can connect between each other. And then again, for each modification you make on the circuit. As you can guess, this would quickly be messy and non-reliable. The breadboard allows you to connect all your components with your Arduino and between each other in an easy and practical way. Then, modifying the circuit can be as short as a few seconds. So, how does the breadboard work? Let's have a look with the Tinkercad simulation here, and then I will show you with the real physical breadboard. So on Tinkercad, you simply go on the component on the right here, and you can start to search for breadboard. You have different kinds of breadboards. Basically, they are all the same. You can have a small one and breadboard. So this is the standard one. So standard size, and this is half the size of a normal breadboard. So as you can see, there are many holes here where you can connect wires and components. And what you need to know is that underneath the surface, there are some metallic wires between some of the holes of the board, which make them electrically connected. So the most important thing to learn here is how those points are connected between each other. And you will see it's actually quite simple. And with the Tinkercad simulation, we get a very good and simple overview to understand that. So first of all, you can see that here you have two lines. So you have a plus and minus line, or it can be red or blue. Okay, you have the same on the small breadboard. And those two lines will be used for, so the plus or the red one will be used for power supply, and the minus or the blue or dark one will be used for the ground. So the ground of the circuit is basically a common point between all of your components, and that's very important so you can have a reference point for any voltage in your circuit. So as you can see here, I'm going to zoom a little bit. When I choose one of the dots here, you can see all the dots here connected in the green line, so are the same dots. So if I connect something here, or if I connect something here, that's the same. Okay, so everything you connect on this line will be connected to all of the other components on this line. And the same happens for this line here. But as you can see, the first and the second line are independent. So one line for ground, one line for power supply. And you have the same here, okay, power supply and ground. And on the small breadboard, that's the same. You have ground power supply here and ground power supply here. And then you have many different lines of dots. And as you can see here, the dots are connected vertically here. So on a normal breadboard, you have about 60 something different lines where you can connect components. So if you connect a component here on that point, that will be the same as here. So if you connect two components on that point, they will be connected together. If you connect one component here and one component here, they are separate. And you can see we have all this part here, and all this part on the top is exactly the same, okay? But this, as you can see here, we have 5 connected dots, okay? Those are 5 different connected dots. And with all of those dots here, you will be able to create any circuit you want. So the most important thing to remember is you have a ground line, a power supply line, and then many different lines, okay, that you can use for your components. If you have any doubt, just go to the Tinkercad and use a breadboard from the components, and you will see it's very easy to check what is connected to what. So here is my physical breadboard, so maybe you have something similar. So this is the exact same thing as I showed you on Tinkercad. You have here, so we have two lines. We have the plus line and the minus line. So all the dots in this line are connected together. All the dots in the minus line are connected together. You have the exact same on the top if you need to. And then we have many different lines here that you will use to connect your components. So for example, on mine here, 45, all of the 5 dots that you see here are connected together. And well, that's pretty much it. Welcome back, this is episode number 8 of this tutorial series on Arduino for complete beginners. So, in the previous tutorial I explained to you what a breadboard was, and now we are going to focus on the resistors you are going to use to create your own Arduino circuits. For many hardware components, we will need to add a resistor to reduce the current which goes through a component. Basically, for a same applied voltage, the higher the resistor, the lower the current. For example, if we just plug an LED like that to an Arduino pin, the LED might be damaged or destroyed because it can't handle too much current. So we will add a resistor. For this course, you will only need 220 ohm and 10 kilo ohm or 10,000 ohm resistors. I won't go into much details about the computation for those values, but they are pretty standard though and can be easily found on the internet. Whenever you need to connect a component to your Arduino, as a first step, you can just make a quick Google search and you will know what resistor you need to use. And then if you want to dive deeper, you can decide to learn more about the electrical theory. So for an LED, a pretty standard value is 220 ohm. You will find this value in many different projects. Now, if you don't have 220 ohm resistors, you can use values like 330 ohm or 470 ohm resistors up to, let's say, 1 kilo ohm, which are pretty common too. And if you don't have 10 kilo ohm resistors, you can find another one between 5 kilo ohm and 20 kilo ohm. But if you have any standard resistor kit, this is 99% sure you have the values I'm going to use. And now that you know what values you need for the resistors, the next part is to know what resistor to pick using the resistor color code. As you can see in your resistor set, the value of the resistor is not printed on it. Instead, you get 4 or 5 color bands which you have to interpret. Don't worry, this is not difficult to do at all, and I will give you a few tools that will assure you that you don't make any mistake. First, here is a table showing you what color corresponds to what number and in which order. So usually you'll see either 4 bands or 5 bands in your resistor. In my personal kit, for example, I have 5 bands resistor. If you have a 4 bands resistor, the 2 first bands represent a number. So for example, if this starts with red and red, well, you can see here that the value should be 2, okay, and 2. And here you need to put the 2 numbers together, okay? This is not an addition. This is not, the value is not 2 plus 2, 4. The value will be 22, okay? 2 and 2 together makes 22. The third band, so the third band will be here because you don't have this band for a 4-band resistor. So the third band will be the multiplier. So if you have a band, let's say brown, then you take your first number, which is 22, and you multiply it by 10. So this becomes 220 ohm. And the fourth band is the tolerance, basically how much the real value can deviate from the one you have read. You will usually see brown, gold, or silver for respectively 1%, 5%, and 10% tolerance. Actually, you don't really need to care about this last band. Most of the circuits you will make don't need precise resistor values. And if you have a 5-band resistor, then you don't take 2 bands to make the first number, but you take 3 bands. So if you have 2, 2, and 2, let's say you have red, red, and red, then you have 222. And then if you have a multiplier, let's say brown, so you will have 222 times 10, which make 2220 ohm. And then the tolerance. So here are the values we are going to use. So first, 220 ohm. So for a 4-band resistor, this will be red, red, and brown. Okay, 22 times 10. And for a 5-band resistor, you will get red, red, and then black. Okay, because black is 0. So 220. And in this case, you don't need to add any multiplier. So the multiplier will be 1. Okay. 1 like here in black. So red, red, black, and black. And then the tolerance. And for 10 kilo ohm, if you have a 4-band resistor, this will be first brown and black to make 10. And then you choose orange, okay, orange, which is 1000 ohm or 1 kilo ohm. And for a 5-band resistor, well, you first choose 1, 0, and 0. So you always choose the number that will correspond to the beginning of the number of the resistance value you want. So this will be 100, and now you just need to multiply 100 by 100 to get 10,000. So brown, black, black, and red. And if you want a quick tool to easily find what is the value for any resistor you have, well, simply you can go on Google and search for resistor color code, and here I have put DGK. So you can type this on Google and then you will see the resistor color code calculator on DGK website. And here you can easily find what is the value of the resistor you have. So let's say you have a band which is red, and then you have brown, and the tolerance, we don't really care about it. And you will see that you have a 220 ohm resistor. Okay, so you have the 4 bands and the 5 bands. So for 5 bands, we have red, red, and then it will be black, and then it will be black, and we still get the 220 ohm resistor. Alright, and now you can see that for any color you have, you will find the values. So for example, 330 or 470 here, like this. Okay, so you can get any value for 4 bands and 5 bands resistor. And lastly, if you go back to Tinkercad, so the simulation, here on the right on the components you can find resistors. So if you don't see the resistor, you simply search here, and then you can put a resistor here. So I'm going to do this to make it rotate. I'm going to put 2 actually. Okay, and so when you have the resistor here, you can put any value you want and choose the multiplier here. So let's say I'm going to put ohm, and I'm going to put 220 ohm. And you can see here we have red, red, and brown, which is exactly what we have computed before. For this one, let's keep kilo ohm, let's put 10 kilo ohm, and you have brown, black, and orange. Okay, so on Tinkercad you will only have 4 bands resistor, but this is, as you can see, another way of finding what should be the color of any resistor you want. And welcome back. This is episode number 9 of this tutorial series on Arduino for complete beginners. So in this tutorial, you are going to create your first circuit. For that, you will need to have an Arduino board, a breadboard, an LED, and a 220 ohm resistor. If you are not sure about how to read the resistor's value, then please go back to the previous tutorial in the series. Before we go and manipulate real hardware components, Here is a quick word of caution. So in any case, you don't really risk anything for yourself or other persons. The current and voltage inside the Arduino are really not that high. The biggest risk you have is to make a short circuit which may damage a hardware component or the board itself. In most cases, you should be pretty safe. The Arduino is actually quite hard to burn, but it's still possible if you manipulate it in the wrong way. Don't worry though, if you follow a few basic rules, you will have no problem. First, when you want to modify something in the circuit, even just one wire, then if you are not 100% sure of what you do, the best way is to first power off the Arduino, which means removing the USB power cable from the Arduino side or the computer side. Make your modifications, double check your circuit, and power the Arduino again. Second, double or triple check all your circuits before you power on the Arduino. This will make you avoid very simple mistakes, like for example connecting 5 volts or a digital pin directly to the ground. I personally double check all my circuits, even for the most simple ones. Third, now when the Arduino is powered on, don't use any metallic tool like a screwdriver or a pen to touch the circuit. With this, you already have a chance of creating a short circuit and thus burn a component or the Arduino board. And finally, 4, when you build a circuit, you will connect multiple hardware components together and or with the Arduino pins. Make sure that all your components are connected to the same common ground. This is super important, both for safety and to get correct results. A good practice is to first connect the ground whenever you add a new component. And we will see more about that in the following lessons of the course. Alright, now don't be too scared of manipulating your Arduino board. If you follow those basic recommendations, you should be totally safe. And now let's build that first circuit. Let's create your first Arduino circuit with one Arduino board and one LED. To show you how to create the circuit, I will first use the Tinkercad simulation, and then just after this in the same video, I will show you how to do it with the real Arduino and real hardware component. I start with Tinkercad because this is easier to explain things because the interface is already well made and you can clearly see what are the different connections of the circuit. So on Tinkercad, I'm going to create a new circuit. Okay, and the first thing we are going to need, of course, is the Arduino board. So I'm going to import the Arduino board and I'm going to import also a breadboard. So not the small one, but the kind of the normal one. And I'm going to put it here and the Arduino here. Okay, like this. And then what are the components we need for the circuit? Well, we first need an LED. So I'm going to pick an LED. You can choose the color of the LED. So, well, we are going to keep red. And I am going to use a resistor. Okay, and let's pick a resistor here. And we are going to use 220 ohm resistor. So choose ohm here and 220, and you should see here red, red, and brown. Alright, so we have all the components we need, and actually for the wires, we are going to directly be able to create wires like this, okay, by clicking on the different dots. So you can press, if you create a wire, you can press escape to cancel the action. And now the first thing we are going to do is, if you remember, we are going to connect the ground with all the components. So first we have a breadboard and an Arduino board. We need to connect the ground of those two components. So where is the ground on the Arduino? Well, ground is represented here, as you can see, by GND. So you have one GND here, you have also one GND here, and another one just on the side. I'm going to use that one, but you can use any GND you want, okay? So let's make something nice here. You can make some clicks. Okay, and let's connect the blue line here with the GND. So now everything you connect to this line will be connected to the Arduino ground. And for ground, there is a standard color, so the convention is to use black wires. So I'm going to use black wires for ground stuff, so everything related and connected to ground will be black. And any other wires, I will choose another color than black, okay? So now the breadboard and the Arduino are correctly connected through the ground. I will put first the LED here. Let's put it there. So I'm going to connect one leg of the LED to one line of dots, and the other leg to a different line of dots. Okay, don't connect the two together. And then you have, so you can see we have two legs, and one that is called cathode is actually the shorter leg, and one that is called anode is the longer leg. So as you're going to see with the real LED, one leg is here bigger than the other one. So now that we have plugged our LED to the circuit, we are going to take the shorter leg and connect it to the ground. So to connect to the ground, we don't need to connect it directly to the Arduino board. We can just connect it to this line, any point in this line. So I'm going simply to click here and click here, use the color black, and that's it. So I chose this point, but I could have chosen any point here on this line, and also instead of here, I could have connected this wire to any point in this line, but I'm doing that to keep things organized. And then what we need to do is to connect the longer leg of the LED to a digital pin of the Arduino. So you can see digital pins are here. So we can actually control the LED. And we are going to use pin number 12. But we are not going to connect directly this to pin number 12 because we need to use a resistor between the pin 12 and the LED, so we can limit the current that goes through the LED. So I'm going to make it rotate like this, and I'm going to connect one leg of the resistor to the longer leg of the LED. Okay, so for LED, there are two different legs. Okay, you need to pay attention to that. But for resistor, well, you don't really need to care about what sense you plug a resistance. There is no direction for resistance, okay? So this or this leg will be fine. So now we have this leg which is connected here. As you can see, this is the same line, so we could put the resistor here, here, or here, or here. It's the same. And then we need to connect, of course, this part of the resistor. So I'm going to click here. And let's connect it to pin number 12. And for the color of the wire, well, I can keep green here, no problem. I'm going to rename here the circuit to LED. And well, that's it for the circuit. And now let's see how to do the circuit with the real hardware component. So first of all, you can just unplug your Arduino. So I'm going to remove the USB cable. You have your Arduino here, which has nothing for now. The breadboard, we will need a LED. So you can see here, I have a red LED and one leg is shorter than the other one. Okay, you can see we have longer leg here on the left and the right leg is shorter. Then we have our 220 ohm resistor. Okay, and we have two wires. Okay, so one wire that should be black if you can, so male to male wire, and another one, okay, that can be any color. I have chosen green here, but do with what you have. So the first thing I'm going to do, I'm going to connect the ground. So I'm just going to do the same steps I did for Tinkercad, right? So I'm going to connect this ground here. Okay, as you can see, we have a ground, so the same one as before. I'm going to connect it to right here, this line, okay, with the minus. So all this line here will be connected to the ground of the Arduino. I take the LED, the shorter leg here will go to the ground. So what I did with Tinkercad is I first plugged the LED like this and then connected this leg to the ground. But what I can do with the LED directly is simply to connect the shorter leg to the ground, okay, just like this. I don't need to add another wire, okay, this will make the circuit a little bit simpler, okay, with less wires. Okay, so now you can see I have one leg, so the shorter one, connected to ground, and then the longer one is connected to one of the lines here. So then I take my resistor, I put it between one, here, let's put it there. So between the longer leg of the LED here and another dot with another line. Okay, this is important. And finally, what I'm going to do is I take my last wire, I connect with one dot here on the line connected to this side of the resistor, and I'm going to put it to pin number 12. So actually I'm going to use the Arduino like this, so it's like Tinkercad but just reversed, and I'm going to choose pin number 12, which is right here. All right, so quick recap here. We have ground connected to the minus line here, and then we have the LED between ground and this dot, and then we have a resistor between the longer leg of the LED and another dot on another line, and finally this leg of the resistor is connected to pin number 12, and the circuit is now complete. So what you can do now, after you double and triple check that, you can power on the Arduino simply by connecting it to your computer, okay, and then you will be able to write a program and upload the program to do something with this LED. And now that the circuit is done, let's not waste any time and let's write some code for this new LED. Make sure you have correctly followed the previous tutorials, because here I'm going to reuse the code we wrote for the LED before. What I'm going to do is I'm going to do File, Open, or you can do Control O, and well, here you have the different programs and projects you have created before, and here the first program, it's what I need here. And you will see that it is exactly the program we need to make the LED blink. So what we have done here is, first in the setup we use the pin mode to make the pin 13 as an output pin, okay, the pin 13 which was connected, if you remember, to the integrated LED. And then in the loop we do digital write high to power on the LED. We wait for 1 second, and then digital write with low to power off the LED. So what has changed? The thing is, we want the exact same behavior. Just what has changed is the pin number, because now it is not 13, but now it is 12. So I'm going to change 13 to 12 here, and also here, and also here. So make sure you change to 12 for every function that requires the pin number. Also, if at this point you are confused with what is a digital pin, what are the pin mode and digital write functions, well, that's normal, and I will explain to you everything quite soon in the course. Right now, the important thing is to be able to make that LED blink with the circuit you have just built. So this program should be it. And now what you do, of course, is you plug the Arduino board to your computer. You make sure on tools that you have the correct board and the correct port. And then you can just, so you can verify or you can directly upload, which will verify and upload. Okay, done uploading. And you can see your first LED, the first real LED that you have plugged to your Arduino, is now blinking every 1 second. Wow, you are still here, congratulations. Why I say that is because, well, actually many people give up on tutorials after just a few minutes, but you have made it until this point, and I have the feeling that you're going to continue and become a pro Arduino maker. If you are enjoying this tutorial so far, you can check out the full course named Arduino for Beginners, which actually contains 7 times more content than this 2 hours tutorial. I will leave a link in the description if you are interested. Alright, and let's continue with the video. Welcome back everybody, this is episode number 10 of this tutorial series on Arduino for complete beginners. So now that we have a circuit with an LED and that we have written some code with the digital write function, well, you might actually wonder, how does the digital pin work with this output mode for the LED? And well, that's a really great timing for you to ask this question, because that's exactly what I'm going to explain right now. To be able to fully control an LED, you need first to understand how to use digital pins on Arduino. So on the Arduino board, you have 2 kinds of pins to control hardware components: digital pins here in orange and analog pins in green. On the Arduino Uno, you have 14 digital pins. As you can see here, the pins are represented by a number from 0 to 13. On different Arduino boards like Arduino Nano or Mega, you may have a different layout for the pins or even a different amount of digital pins. But if you understand how digital pins are working with this Arduino Uno example, then it will be very easy for you to work with any other Arduino board. So a digital pin can be used either to actuate a component, such as an LED like we did before, or to read from a sensor, for example, a push button. Now, how to work with digital pins? Well, the first thing you need to do is to set a mode for the pin. You can choose either input or output mode. In this lesson, because we are working with an LED, we will only focus on the output mode. And then, once the pin is set as an output pin, you can change its state. For that, you have 2 options, high or low. This is a binary state. High means that the output will be 5 volt, because that is what the Arduino delivers, and 0 means 0 volt. So if you put an LED on a digital pin and set the pin state to high, the LED will be powered on. Then if you set the state to low, the LED will simply be powered off. And now that you have a better understanding of digital pins as output pins, let's quickly make a recap of how to work with an LED. So here in our circuit, we already have the LED plugged on pin number 12. So the first thing I'm going to do is to do a define with LED pin 12. So I'm going to create a constant here with define LED pin all uppercase with an underscore, and then directly the value. So whenever we need to use this number in our code, okay, for the LED pin, we just need to write LED pin instead, which will make it much easier later on if, for example, we want to change the pin where the LED is attached. So first step, you use a define to easily get access to the pin number in your code, and then in the setup, so I'm going to remove that comment. in the setup, you will use the pin mode function here to set the mode of the pin. So for now, we have seen only the mode output. So the first parameter here is the pin number and then the mode. So the mode will be output, all uppercase, and it should turn blue, okay? Once you have done that, the pin 12 is defined as an output pin, okay, not an input pin. So from now on, after you have used the pin mode function, you can change the state of the pin. And we can directly do that here if we want to. Digital write LED pin with, let's say, high, because it will be low by default. So we set the mode, and once we have set the mode, we can directly set the state, whether high or low. So now let's say in our program, we want to make the LED blink, but first, when we start the program, we want the LED to be powered on for 3 seconds. So for example, we can do delay 3000 here. So we power on the LED, we wait for 3 seconds, and then we will enter the loop function, okay? And in the loop function, well, digital write LED pin. So here maybe we are going to start with low and then wait for, let's say, 500 milliseconds, and then digital write LED pin high, wait for another 500 milliseconds. All right, and we have our blink example right here. So nothing complicated, as you can see. First we set the mode, and once the mode is set, we can just change the state as many times as we want. So now let's upload this program here. Name it LED. All right, and you should see the LED powered on for 3 seconds, and now the LED is blinking. Hey, welcome back. This is episode number 11 of this tutorial series on Arduino for complete beginners. So in this tutorial, we are going to focus on the Arduino PWM functionality. Let's come back to our digital pins on the Arduino Uno. As you can see, some of the pins have a PWM function. I'm going to explain what is PWM just in a moment. So you can recognize them with the tilde near the number for the pin. On Arduino Uno, out of the 14 digital pins, 6 of them can be used as output pins with a PWM. They are pins number 3, 5, 6, 9, 10, and 11. Now, what is a PWM? PWM means pulse width modulation. That's quite a complicated name, but you will see it's quite easy to understand. When you use a digital pin with a binary state, either the voltage is high, which means 5 volt all the time, or low, which means 0 volt all the time. With a PWM, you can choose to make the signal high only for a fraction of the time, and this fraction of the time in percentage is called the duty cycle. So here we have 3 examples. First, with a duty cycle of 0%. This means that the signal will be high 0% of the time. Thus, the signal is always low. In practice, this is the exact same as just using digital write with low. If we look at the third example on the bottom, here we have a duty cycle of 100%. That means that the signal will be high 100% of the time. Thus, the signal is always high. In practice, this is the exact same as just using digital write with high. And now the interesting part. If you look at the example in the middle, you can see we have a duty cycle of 25%. This means that the signal will be high 25% of the time and low 75% of the time. In practice, for example, when you power on an LED using the PWM of a digital pin, well, if you set 25% of the duty cycle, it's very similar as if instead of supplying 5 volt to the pin, you just supplied 1.25 volt, which corresponds to 25% of 5 volt. Thus, you can expect the LED to be powered on, but with a lower intensity. To make it simple, just think about the duty cycle of the PWM as a percentage of the total voltage. And you can see that if you modify the PWM duty cycle between 0 and 100%, you can have much more control over the average voltage you supply to your components. Now, on the Arduino, the percentage will be represented by an integer number between 0 and 255. 0 is of course 0% and 255 is 100%. If you want to apply a 25% duty cycle for the PWM, you will then need to give 25% of 255, which is about 64. So let's complete our diagram. We are still setting the mode for the digital pin as output, and then we have two options. Either we use the pin with a binary state, which means we use the digital write function with high or low, or, and this only applies to pins with the PWM mark, we can set an analog value using the analog write function and provide a value between 0 and 255, which corresponds to the percentage of the duty cycle. Let's now see how to actually use the digital pins with a PWM function on the Arduino. And we are going to use the analog write function that I'm going to explain to you in just a minute. But first, we need to change something in our circuit. Why is that? So we have our LED, which is correctly plugged to the Arduino, but if you look at the pin here, we have plugged the LED to pin number 12. Okay, and the PWM function is only available here when you see the tilde, okay? So for example, pin number 11, 10, 9 here would do, but not pin number 12. So if you want to be able to use the analog write function for this LED, okay, to provide a PWM, you need to change the pin. So what I'm going to do is simply, so I click on the wire here and there is this dot that I'm going to change here to pin number 11. All right, nothing else to change, okay, we just changed the digital pin for the LED and now the LED is connected to a pin that has the PWM function, so we can start to write the code. And how to change the pin on the real Arduino? Well, it's quite simple. So first make sure that you have unplugged your Arduino board. And then you simply, so you don't change anything, you simply unplug here this wire, which is on pin number 12, and you just put it on pin number 11 right here. Okay, and that's it. And now back to the Arduino IDE. So back to the IDE, and you can plug the Arduino board to your computer and make sure you have the correct board and the correct port here. And let's see how to use this analog write function. So I'm going to remove here the comments. And first, as usual, I'm going to use a define, okay, for the LED pin. So this time it's not 12, this time it's 11. Now in the setup function, what I need to do is pin mode LED pin output. Okay, so to initialize the pin, okay, to set the mode for the pin, as you could see in the diagram in the previous lesson, we still need to set the pin to output mode, okay? Whether you use digital write or analog write, you still need to set the mode as output. So now the pin has been initialized in the setup function. Let's directly use the analog. So analog write, okay, you can see it turns orange like this. So analog and then uppercase W. I open the parentheses. Here I need to provide first the pin number, LED pin, just like we did in digital write. And then in digital write, we directly set high or low state. But with analog write, we are going to provide a number, so an integer number, between 0 and 255. So let's test, let's say 20. So I close the parentheses and don't forget the semicolon. So here the program will simply initialize the LED and set an analog value, so a PWM with a duty cycle, okay, which is 20 out of 255, which is a little bit less than 10%. Okay, and let's actually compile and upload the code. I'm going to name it analog write. And as you can see, the LED is powered on, but the intensity is quite low, okay? Now let's test with 200, which corresponds to about 78% of the PWM. So the intensity here should be much stronger. So let's try that. All right, and as you can see, your LED now is powered on again, but with a higher intensity. So you can try all kinds of value, okay, between 0 and 255 to see how the brightness changes with different values. And now let's try the two special values, which are 0. So 0 means 0%. So if you send analog write with 0, the LED will simply be powered off. And with 255, the LED will be powered on with the 5 volt, okay, which is just what you would do with digital write and high state. Alright, so as you can see, analog write function is not that complicated. Make sure first that the pin you try to use with analog write has a PWM function, otherwise it won't work. Welcome back to episode number 12 of this tutorial series on Arduino for complete beginners. This tutorial here is another challenge I'm giving to you, with first the explanation of what you need to do and then the step-by-step solution. And your challenge will be to make the LED fade in and fade out, just as you can see on the video right now. So how to do this? I'm going to give you a few hints, okay? So first you will need to initialize the LED like we did before with PID mode, etc. And then to make the LED fade in and fade out, you will actually write code in the loop, okay? And you will need to use 2 for loops, okay? So for loop here to go from 0 to 255, and another for loop to go from 255 to 0. So why is that? Because the analog write function can take a value between 0 and 255. Okay, 0 means powered off and 255 means powered on with the maximum intensity. So you need to go from 0 all the way up to 255, and then once you reach this number you need to go back to 0, okay, step by step, number by number, and every time you will put this number into the analog write function. So you will have analog write with 0, and then with 1, with 2, with 3, etc. But as you can guess, you are not going to write the analog write function 500 times, okay? Instead, you are going to use for loops. So you have already seen how to use a for loop to go from a number to another number by incrementing the index every time with I++, so that you know. But actually, it's not the only way to write a for loop. You can write a for loop to actually decrease the index, okay? I'm just going to give you the structure for that. So you will have your for loop, and then you start the index. Instead of starting at 0, you will start at 255, okay? Semicolon. And then the condition so that the loop can continue is simply that the index is greater or equal than 0. And finally, what we're going to do with the index is not I++, but I minus minus. Okay, I++ means you add 1 to I minus minus means you decrease I by 1. So we start 255 and then 254, etc., all the way down to 0 and then stop. All right, so with that, you should have enough information to do the activity. And also what you're going to need, the last thing, is to add a small delay, okay, between each analog write that you do, because if you do it at full speed, it will be way too quick for you to see anything. So you can add a delay of 5 milliseconds, okay? Between each iteration of the for loop, you can add a 5 millisecond delay. This is the value that I used in the video that I showed you about the result. Now, of course, you can tinker this value if you want to increase or decrease it. It's up to you. Alright, and now you can press pause on the video, try to do the challenge by yourself, and then watch the solution. And here is the solution to this second challenge or activity of this tutorial series. So we can actually separate this project into two parts. First, we need to make sure that we have the index going from 0 to 255 and then 255 to 0. And then we need to set up the LED and use the analog write function. So I'm going to work first on the two for loops we need to do. Okay, and make sure we have the correct values using the serial monitor for debugging. And then I'm going to write the analog write function. So I'm going to remove all of the comments. Okay, and start with the first for loop. So for, and then we create, of course, an index int I is equal to 0. So we start at 0. And then what is the maximum value we want? The maximum value we want is 255. So I is lower or equal than 255. We could also use I is strictly lower than 256. And then I plus plus. So the for loop, we go from 0 to 255, increasing by 1 every time. Okay, that is the first for loop. The second for loop, so I'm going to put here space. We are going to start from 255, okay, and we are going to stop at 0. So while I is still greater or equal than 0, we continue, okay? You can read this as while this is true, we continue. And then I minus minus, which means that we are going to decrement this index every time. Okay, and now the for loops are complete because here you can see we start at 0, we go to 255, okay, in this one, and then from 255 to 0, okay, and once we have finished those two for loops, well, we go out of the void loop and we go in again, and we start again at 0. So there is a continuity with the index here. And now what I'm going to do is simply print to be sure that we have the correct values. So serial.begin, okay, don't forget that, with 9600 baud rate in the setup function. And here I'm going to do serial.println with I, and also serial.println with I as well. And as you can see here, we use the same name I because this is a different scope, okay? Here the I variable is local to the for loop, so basically it is contained between those two curly brackets, okay, in this scope, and this I is in that scope, okay? So two different scopes. And now what I'm going to do, I'm going to add here delay 5, okay? I'm going to add the delay because if we don't add the delay, it will print very, very fast and it's not that readable. And well, let's try this first part. So I'm going to compile the code as activity 2. Okay, let's see if we have any error. No, done compiling. So now tools, board, and ports are correct. Actually, well, just for printing, I'm going to increase this delay a little bit because that's going to be a little bit too fast just for us to read the value. So a delay of 50 milliseconds will be good. I'm going to upload the code now. Loading, I'm going to open the serial monitor, and you can see we go from 0, okay, it's increasing. So 150, 200, and then 200, you will see here 255, and then we decrease the value. Okay, so 100 here, we go down and we are approaching 0, and you will see here 0, and then we go up again. So now we are sure that the index here, the I value that we need for analog write, has the correct behavior. Okay, so what we can do now is actually to set up the LED. So define LED pin 11. In the setup function, we are going to do pin mode with LED pin and output. And in the void now, instead of printing here, so we can remove that. Actually, I'm going to comment it. Instead of printing I, we can directly do analog write with LED pin and the value I, which we know is going from 0 to 255 here. I'm going to put back the delay to 5 milliseconds. And then on the other for loop, analog write LED pin I as well. Okay, this is the same code, but here the I is going from 255 to 0, and also the delay 5. And let's run that code. So now we don't check the side monitor, we check directly the LED. And as you can see, the LED is fading in and fading out, just like we wanted. So as you could see on this program, sometimes it's easier to break the program, break the project into different steps and try to validate each step one by one. Okay, once you validate one step, like we did here with the index, we can go to the next step. And this way, creating projects will be much easier for you, and you will make much less errors. Welcome back to episode number 13 of this tutorial series on Arduino for complete beginners. So in this tutorial, I will show you how to add a push button to your circuit, which already contains an LED. To add the push button, you will need, of course, a push button component and also a 10 kilo ohm resistor. So I'm going to show you exactly what to do on Tinkercad, and then you can follow the exact same step to do the real circuit, and I will show you the result also with the real circuit. So we are not going to start an empty project here. We are going to use what we already had before. So here, what you can do here, we have our LED circuit. You can click on these settings here and click on duplicate. So we are not going to modify directly the LED circuit. We create a new one, okay, which is a copy of LED. Let's name it push button. Okay, and now we are going to add the push button right here in this circuit. So the first thing we can see is that we already have the connection, okay, between the ground of the Arduino and the ground here, this line that we set up as the ground of the breadboard. So I'm going to add the push button here on the right, and you can see here on the list of components we already have push button here, but as a wait, if you don't have it, you can directly search for it. So I take my push button, I put it there, and then we will also need a resistor. So I'm taking a resistor, and this resistor will be a 10 kilo ohm resistor. So kilo here and 10 here. And as you can see, we have brown, black, and orange. I'm going to make it rotate like this. All right, and that's all the components we need, plus the different wires, okay, but the wires, we are going directly to create it from the board. That's all the components we need for this circuit. What we are going to do is take the push button and place it here, okay, between the two sets of lines here on the breadboard. So you have one leg here, one leg here, another one here, and another one here. We are going first to connect this push button to the ground, and to do that, we are not going to directly connect to the ground, but we are going to add a resistor, Okay, so I'm going to explain just after why we add a resistor here. So on this leg here, you can connect one resistor and then connect the other leg of the resistor here to another line. And then I'm going to take this and connect to the ground. So make sure this is the ground line. Okay, yes, this is the ground line. I'm going to put this in black because this is the convention for ground. And that's the first connection we need to do. Now the second connection is we need to connect this leg, okay, on the other side of the button to the 5-volt supply of the Arduino. So we can see here we have a 5-volt supply. And instead of just putting a wire like that to the 5-volt, I could do this, okay? But instead I'm going to connect the 5-volt here to the plus line, okay? So I'm going to put it there, and with the color red, okay? Red is the convention for power supply. So I'm going to use red only for power supply and not for anything else. And I recommend you do the same. Black and red are for ground and power supply. So the 5-volt here goes directly to this line, which means that now all this line is connected to 5-volt. And you will see in the following of this course, we actually need to connect multiple components to the power supply. So this line will be very useful. So what we can do, I'm going to take one dot from this line, okay, any dot, and connect it to the line of the 5-volt. Make sure that you don't connect it to the ground, okay, but to the line of 5-volt, and put it color red. Okay, so you can see by using the different colors, red and black, we can easily make the difference between ground and 5-volt. So in the future, we will make much less mistakes. All right, so we have this pin connected to ground with resistor and this pin connected to 5-volt. Now I'm going to take the pin which is on the other side here of the button, okay, on this side, which also corresponds to the side of the ground, okay, and I'm going to take one dot, so let's say this one, and I'm going to connect it now to digital pin number 2, like this. You can make it square like this. Okay, that's better. So with this pin number 2, we are going to be able to read the state for the push button. And right, the circuit is now finished. And just why did I add this resistor here connected to the ground? Because this is actually not mandatory. This resistor will act as what we call a pull-down resistor. What is a pull-down resistor? Well, when you just have a push button here, and you have so ground and power supply, and then you read the state from that pin, the state of the button, so the voltage that is applied to the button, may be floating, which means that it can be anywhere from 0 to 5-volt, and the voltage will continuously change. By adding this resistor here connected to the ground, what we do is we force the default state of the button to be low, so to be 0-volt. And you could do the same thing with a pull-up resistor. So instead of connecting a resistor to the ground, you would connect it to the power supply, and then instead of using this line for the digital pin, you would use the other one. And thus, with this setup, the default state for the push button will be high or 5-volt. Okay, so here, by doing this, so with a pull-down resistor to 0-volt, when we read the state for the push button, when the button is not pressed, we will read the state low, and when the button is pressed, we will read the state high, and we don't need to worry about the voltage here floating between two numbers. Alright, and this is the real hardware circuit. So first, make sure that you disconnect the Arduino board, so at least one of the two part of the USB cable. Here I've just removed it completely. And then, so we have, what do we have on the circuit? We have our push button here, which I have connected just like in the Tinkercad simulation, okay, between the two parts, between the two sections of the breadboard. Then I have my pull down resistor, which is a 10 kilo ohm resistor. But as you can see here, instead of connecting the resistor between this leg of the button and another line and then adding a black wire, I just directly connect the resistor between the ground and this leg of the resistor, okay, because this is very near, I can save a wire there. Then I have added here this wire, okay, between, you can see the 5-volt pin of the Arduino, and here this line, okay, so I have the ground, okay, the ground line and the 5-volt line. So now all this line here in red is connected to 5-volt, and I have a small wire here, a red wire, between this line and this pin of the button. And finally here on this side, okay, which is the same side as the ground side, I have another wire, so I chose green as well. Another wire, this is connected between this pin and here the pin number 2 of the Arduino. Alright, so now you have your LED here and the push button here, and the two lines, so the plus and minus lines, are connected respectively to the 5-volt and to the ground. Hey, welcome back! This is episode number 14 of this tutorial series on Arduino for complete beginners. So in this tutorial, we are going to use the push button we have just added to our circuit during the previous tutorial. Basically, what we want here is to know if the button is pressed or not pressed. And to do that, we will need to work with digital pins with the input mode. And again, you might ask, what is this input mode and how does it work? And once again, great question. Let me explain that very quickly. You will see working with digital pins as input pins is really easy once you have already understood how to work with them as output pins. So let's come back to our previous diagram. What you've seen for now is that in order to use a digital pin, first you need to set its mode. So you can choose to set the mode as output, and then you can either change the pin state with binary high-low state, or for some of the digital pins, you can set an analog value. Now if we come back to the part where we set the pin's mode, the other option here is input. And when you choose input, then what you can do is to read a digital value from the component. This value will be binary, either high or low. If the voltage on the pin is close to 5-volt, you will get the value high, and if the voltage is close to 0-volt, you will get the value low. Note that you can't read analog values when using a digital pin as an input pin, only high and low states. For example, with the push button in the next lesson, when you read the pin state, you will directly know if the button is pressed or not. And to know that, you simply have to check if the state for the pin is high for pressed or low for not pressed. Now that you understand digital pins as input pins a little bit better, and that you have set up your circuit with the push button, let's actually read the state from the push button. So the first thing I'm going to do is, of course, because we are using a pin, I'm going to use the define here, just as we did for the LED, but here we are going to name it button pin, okay? And the pin number is digital pin number 2, so I write 2. Next, I need to set the mode for the pin, okay? Either input or output. So here, because we want to read something from the button, I'm going to use pin mode with button pin and input. Okay, so you can see input should also turn blue, okay, because this is a keyword recognized by the Arduino IDE. And then what I'm going to do is, in the loop, I am going to print the state of the button every 100 milliseconds. So to print, I'm going to first serial.begin. Okay, so I initialize the serial communication. And here I am going to do serial.println, so we print with a new line every time. And what do we print? We print digital read, so you can see digital read should turn orange, and then digital read will take just one parameter, which is the number of the pin, so button pin, which is defined here as 2. Okay, so we call the digital read function. The result of this function will be given to the println function, which will print the state of the button. And then, because we don't want to go too fast for our eyes, we just add a delay of, let's say, 100 milliseconds. So we are going to print the button state at 10 Hz, okay, 10 times every second. Make sure that you have correctly plugged your Arduino board, and I'm going to first compile, so push button. Alright, done compiling. I'm going to upload the code and open the serial monitor, and you can see we have 0. So we don't have low or high, okay, printing on the serial monitor, because low will be evaluated to 0 when you try to print it, okay? And now I'm going to press the push button. I keep the push button pressed, and you can see we have 1. Okay, I release the push button and we have 0. I press the push button, we have 1, which corresponds to high, and I release, we have 0. So it's working. Okay, great. So now you can actually know very easily with just this line of code plus one line of setup, you can know what is the state of the push button. Is the push button pressed or not pressed? And let's improve this code just a little bit. So instead of just printing the state, we can print some text, which may make more sense, okay, for humans who read the serial monitor. So I'm going to remove that, and I'm going to do if, okay, digital read button pin. So I'm going to compare the result of this function, so which will be either high or low, to, so equal, make sure you put 2 equal sign, high, okay. If what we read from the pin of the button is high, then we are going to enter this block of code, and I'm going to do serial.println button is pressed. Okay, and then we can do, so we could do else if digital read of the button pin is equal to low, okay, but because this is the only other solution, okay, because this is a binary state, I just need to write else serial.println button is not pressed. Like this. We keep the delay here so we don't print too fast. So now we are going to print either this text or this text, depending on if we press the button or not. Let's upload the code and let's open the serial monitor, and you will see button is not pressed. Now I'm going to press the button again. Button is pressed. I release the button. Button is not pressed. All right, so this will actually make more sense if you want to print something for a user to see what's going on in your application. So to recap, if you want to read data from a digital pin, first you define the pin here, then with pin mode you set the mode to input, and then you can just use digital read to read the state from the pin. And one very useful thing to do is to compare this with high or low, so you can use a if structure, okay, a condition with an if-else structure to decide what actions you are going to take depending on the state you read from the digital pin. Welcome back to episode number 15 of this tutorial series on Arduino for complete beginners. In this tutorial, we are going to make the LED and the push button work together. And once again, like I did previously in this series, I'm going to show you the problem we want to solve as a challenge, and then I'm going to write the solution with you step by step. So for this activity, you can create a new project here. And your challenge will be to combine the two components that you have for now, the LED and the push button. So you will power on the LED only when the button is pressed. If the button is pressed, you power on the LED. If the button is not pressed, you power off the LED. So you will need, of course, to initialize your components here. So I advise you to start from a blank page, okay? So you can write all the code from scratch, like here with this empty program. So you will initialize your component, and in the loop, you will need a if structure, just like we used previously. So you will need an if structure to check whether the button is pressed or not, and then you can decide to take an action, which is power on the LED or power off the LED. Alright, and now you can press pause on the video, try to do the challenge by yourself, and then watch the solution. And here is the solution to this third challenge or activity of this tutorial series. So first things first, we are going to initialize here the pins, and before doing that, we are going to use define for LED pin. So this is still pin number 11, and another define for button pin, which is number 2. Okay, so for every pin you are going to use in your circuit, in your program here, well, you can just add a define for each pin. And then in the setup function, so here we're going to use pin mode, okay, to initialize the LED pin to output mode, and pin mode for the button pin for input mode. Okay, so here the order is not really important, you just initialize all the pins, so you could initialize the LED first or the button first, it doesn't matter. And now that the pins are set up, directly after the pin mode, so here in the setup or for example in the loop function, we can start to read the button state and we can start to control the LED. So in the loop, what I'm going to do, I'm going to write if digital read button pin. So if this is equal to high, okay, and make sure you use 2 equal sign, okay, if you just use 1 equal sign, you may have some weird errors here. So 2 equal sign. If the button is pressed, so we can read this line as if the button is pressed, then we are going to power on the LED. So digital write LED pin with high. And else, so if the button is not pressed, we are going to do digital write LED pin with low. All right, and that's about it. So now let's verify, let's compile. I'm going to name it activity 3. Okay, down compiling, so we don't have any error. And I'm going now to upload the code to the Arduino board. So again, make sure the board is correctly connected. I upload the code, and now, so you should see here the LED, so nothing happens for now, the LED is powered off, but actually the LED is powered off because we are in the else here of the if, okay, because the button state is low, so we power off the LED. Now I'm going to press the push button, so here, and you can see the LED is powered on. Okay, I release the push button, the LED is powered on. I press, I release, I press, I release, and every time I press, the LED will be powered on, and every time I release, so every time the button is not pressed, the LED is powered off. Hey, this is Edward. I hope you enjoyed this tutorial series a lot and that you could get some real value out of it. Now, this series is actually a free extract from my much larger course named Arduino for Beginners. This complete course contains 15 hours of content and will take you from a complete beginner to an Arduino maker with a strong intermediate level where you become really autonomous and confident to start any Arduino project you want. So if you like the way I teach and if you want to go further with Arduino, starting from this last tutorial, well, I recommend that you check out the course. The link is in the description. And just in case you're wondering what you're gonna learn, well, here is a sneak peek of what's inside the course. So here is the complete course that you can get with, well, 20 sections, okay, and about 15 hours of content. And if I put here the introduction video, well, here you can see that you're gonna learn the foundations, so the basics, the circuits, programming, digital and analog pins. And so this tutorial series was a part of the foundations, okay? There is not all the foundations, but it's a good part of it. And then you can see we're gonna learn serial communication, work with time, how to debounce the push button, work with interrupts, the EEPROM memory, and then some more electronic components, such as the ultrasonic sensor to measure some distance, LCD screen, an infrared remote controller, and also a photoresistor. And at the end of that, well, this is not the end actually, because we have a big final project where we put everything here into action. And so this is the final project, which is an interactive obstacle detector, okay? And so basically that's something that you could add in a robot, okay, to know when the robot is too close or not from an obstacle. So, well, here you can see all the different lectures, okay? So for each section, for example, debounce the push button, we have many different lessons so that you can correctly understand, and with some activities. Okay, so for now you've done 3 activities, okay? Those were the 3 challenges, but here in this course you have 20, well, here is the last one here, 20 activities plus one big final project, all right? And for each project we do, or each activity, so you get a complete video with step-by-step instructions, and you can also download the Arduino code. You can download the code for every activity and project we do. Okay, so you have everything here waiting for you. All right, thank you for watching, and I hope to see you in the course.